think we're live. Let's see. All right. I think we're set. How are we all doing? Looking through. It's kind of dark in here. It's kind of cloudy outside too, but at least it's more light. Yeah, it's really cloudy outside. Let's see. Let's go over anything from the study guide. So do we have any questions on the study guide? Let me pull it up. We have the free response. We have the multiple choice. Number 2 on the free response or on the multiple choice? Multiple choice. Okay. So number 2 says solve that equation. So let's write it down. It's going to be x over x squared plus 6x plus 9 minus 1 over x plus 3 equals 1 over x plus 1. Okay, so when we're solving rational equations, what we want to do is we want to make the denominator the same. Once the denominator is the same, we can ignore it. We don't have to worry about it. And the main reason is once the denominator is the same, if you multiply everything by whatever that denominator is, everything will cancel out. So what we need to do is we need to figure out what factors exist in the denominator. So I do have this x plus 3. I do have this x plus 1. I need to factor this one. So that will turn into x over, and that's x plus 3 times x plus 3. So now I can see every single factor that I have in the denominator. So it looks like the least common denominator is going to be having 2 x plus 3's and 1 x plus 1. Meaning, to make all the denominators the same, that's like the bare minimum all of them are going to have. So for example, this needs an x plus 1. I'm going to change the color because it'll be easier to see. So this needs an x plus 1 over x plus 1. This needs an x plus 3. So now I have 2 of them. And it needs the x plus 1. And then this one needs 2 x plus 3's. Now, all of these terms, they all have 1, 2, and so they have the 2 x plus 3's, and then they each have the x plus 1's. So now the denominator is the same, if I multiply everything by the denominator, it'll disappear. So what I'm left with is just the top, which is x times x plus 1 minus x plus 3 times x plus 1 equals x plus 3 times x plus 3. So now I just need to multiply all of this out. So I just need to go through, I need to multiply all this out, and this is going to give me, or it's going to allow me to be able to solve it. So distributing this, that's x squared plus 2x. Multiplying all this through, I'm going to get minus x squared, 3x and 1x, so plus 4x plus 3. And that's going to equal, then distributing all this through, x squared plus 6x plus 9. I know the plus 9 got blocked. There's a 9 here. I apologize. So now I need to distribute this negative. So that's going to give me x squared plus 2x minus x squared minus 4x minus 3 equals x squared plus 6x plus 9. I see x squareds. I'm going to combine like terms on this side, so it's probably going to be quadratic. So that cancels out. 2x minus 4x is negative 2x. And then I still have the minus 3. And that's going to equal x squared plus 6x plus 9. So now I'm going to expand this. I'm going to bring all these to one side. So I'm going to bring the 2x over and the 3 over because I know that it's going to be quadratic. Quadratic means I need to have it equal to 0. So I'm going to get 0 equals x squared plus 8x plus 12. This factors. And so x does not equal negative 6. Oh, sorry, I don't know. My brain was on the whole vertical asymptote there. So x is going to equal negative 6 and negative 2. I just need to take a look. If I plug those in back into the original, am I going to have a 0 in the denominator? So if I plug in negative 6, no. If I plug in negative 2, no. And so those are solutions. Let me adjust my mic real quick. There. I know a lot going on with this problem. So let's see, for number 2, I got that. Yep, none of these. It's E. Because the solutions I got were negative 6 and negative 2. None of these were negative 6 or negative 2. So therefore, it's none of these. So let me recap this because there's a lot going on. So the strategy when we have a rational equation is we need to have all the denominators to be the same. Once the denominators are all the same, you don't have to worry about having the numerator. So I factored everything so I can see all the factors, and it seems like to make all the denominators the same, they all need to have x plus 3, and x plus 1. So I multiplied top and bottom by what was missing on each term to make them all the same. Then, once they were all the same, I ignore the denominator. You don't have to worry about it anymore, because if you multiply everything by the denominator, it'll just cancel out. So then I just had the top here, the top here. So I just rewrote what the tops were. And then from there, distribute, see what type of equation it is, and end up being quadratic, which is why I got set it equal to 0, and you just solve it that way. Comments or questions on that one? Okay. Number 5. I'm assuming on the multiple choice again. So on number 5, the rational inequality. So if my inequality is, when it's an inequality and we're dealing with rational means there's something on top and on the bottom. We want to combine it all together, and we want it on one side compared to 0. So meaning if I had something on both sides, let's say it said x over x plus 1 greater than or equal to x, I would subtract the x, bring it over, and try and combine that into one inequality. Find the common denominator, combine them together. Okay? So, but right now, it's how we want it. It's one inequality. So we look at two things. We need to find what are the zeros and what are my critical values or undefined values. So my critical values are what's in the denominator, what cancels out. So in this instance, if I set x minus 2, if I set that equal to 0 and solve, that's going to give me x equals 2. Now my zeros, you take the top, so x squared plus 3x minus 4, and we want to factor that and set it equal to 0. So this will factor into x plus 4 and x minus 1. So x is negative 4 and positive 1. Now I want to take all of those values and we put it on a number line. So my values are negative 4, positive 1, and positive 2. Always your critical values are open circle because they're undefined, meaning we can never equal those values. And then my zeros are either open or closed circle depending on the inequality. Well, because it can equal it, we can say closed circle. Now, all I need to do is test true or false. Another thing that I can do is I can do a sign chart and see where it's positive or negative. It doesn't really matter. We just need to find the area in which it's going to be shaded. That's all we need to do. I like doing the sign chart. It's a little quicker. So the inequality, we interpret it. It's asking for values greater than or equal to 0. So values that are greater than or equal to 0 are positive values. So that means that anytime I get a positive number, it's automatically true. So if I test negative 5 and I plug it into the factored rational expression, So if I plug in -5, you're going to get -1 times -6 over -7. -1, we basically count the negatives. 1, 2, 3. So negative and a negative and a negative is a negative. Now I need to plug in a value here, like 0. So if I plug in 0, I'll do 0 in orange. I'm going to get 4. I'm going to get -1. And I'm going to get -2. So I only have 2 negatives. So a negative is a positive. Then I need to test a value here, like 1.5. I'll do 1.5 in purple. So 1.5 plus 4 is positive 5.5 times. If I do 1.5, I get 1.5 minus 1, so 0.5. And then if I did 1.5 on the denominator, I get -0.5. So a positive and a positive and a negative give me a negative. And then I'll do the last one, I don't know, I'll do this blue color. If I plug in a value right here, like 3, 3 plus 4 is 7, 3 minus 1 is 2, and then 3 minus 2 is 1. So positive times a positive divided by a positive, that's going to give me a positive. So our inequality says the positive values are the true values. So I can shade those in as my answer. And so my answer is going to be from -4 to 1, union from 2 to infinity. So what value is going to represent that? So the interval between -4 and +1. So it looks like A has -4 to +1. So does C. And then the values greater than 2. So then X is greater than 2. It can't be equal to because it's not a bracket, it's a parenthesis. So it looks like it's going to be C. So let's verify that. Bam. Any other questions with that, Jocelyn? Great. Any other questions? Anyone else? Any other questions? Oh, I did the whole blocking thing here. There it is. I'm not on my A game today. I don't know what it is. I feel like maybe I'm getting like a slight sniffle. I think it's because of the weather change and the sinus. I don't think I slept well at all last night. I like woke up and I'm like, why does it feel like a brick hit my head? So I'm a little off today. But here's that purple part. Positive times a positive times a negative. That's why that's a negative. The fifth graph on the free response. So 1, 2, 3, 4, 5. You're talking about this one here. Is this the one that you're referencing, Jocelyn? Okay, cool. So, 3. So I need to find my important values, so the descriptive values, asymptotes. So I need to find those first. To find the asymptotes, I need to factor the denominator. So if I factor the denominator, I get x minus 2 and x plus 1. It doesn't look like anything cancels, so there's no points of discontinuity. There's no holes. I do have vertical asymptotes, and those are at 2 and -1. And then, so holes would be not applicable. There are no points of discontinuity. The horizontal asymptote, because my denominator has a degree of 2 and my numerator has a degree of 0, the denominator has a larger degree, so therefore it's automatically y equals 0. So for my graph, what I would have so far are going to be asymptotes here at -1, asymptotes here at 2, and then an asymptote here at y equals 0. Questions on what I got there so far? Okay. So now all I need to do is you just create a chart, a T-chart. Great. So you create a T-chart and you just plug in values. I'd use a calculator to plug those values in. So for example, I would plug in, the -2, -3, -4. Plug in as many values in between here, because I don't know really what's going on in between. So maybe I would do -0.5, 0, 1, and 1.5. And then a couple values over here like 3 and 4. And what I would do is I would just enter those in a calculator. So let me enter them let me pull up my calculator. So if I plugged in -2, that's going to give me 0.75. If I plugged in -3, that's going to give me 0.3. If I plugged in -4, that's going to give me 0.166. So modeling that real quick, if I say that's 1, that's 2, and that's 3, at -2 is 0.75. At -3 it was 0.3. And then at -4 it was 0.6. So it looks like it's getting lowered. It's approaching it. Maybe if I wanted to plug in, here I'll create an extra XY right here. What if I wanted to plug in, looks like -1.5. Let's see what happens when I do -1.5. That's going to give me 1.7. So then 1.7. So it looks like my graph is doing that. So I have that piece right there. Any questions on how I graphed that part? I'm going to finish the problem though, so no worries. So then plugging in between, I'd plug in negative 0.5. And so I get negative 2.4. If I plugged in 0, that gives me negative 1.5. If I plugged in 1 and 1.5, so if I plugged in 1, that gives me also negative 1.5. And then if I plugged in 1.5, that gives me negative 2.4. If I plugged in 3 and 4, that's 0.75. It looks like because of that, and then 0.3, you see how these are similar to these? That means it's probably going to be very identical. So I don't have to plug in more points. So I have that. So now graphing the in-between stuff. So negative 0.5, we said was negative 2.4. 2, 3, so it's about right here. At 0, it was 1.5. At 1, it was 1.5. And then at 1.5, it was negative 2.4. Okay, so it looks like it does like a loop thing. So it looks like it's going to come up, cross, and then go back down. And so then that would be my graph. The more points that you pick to plug into your XY table, the more accurate that graph is going to look. Any other questions? The 6 graph? Let's look at that one. Okay. So on this one, I have x squared plus 4x minus 5. That's over x plus 1. So for this one here, a few things. So let's factor it and see what's going on. So if I factor it, this will factor into x plus 5 and x minus 1. And that's all over x plus 1. So nothing cancels out. So in terms of holes or points of discontinuity, that's not applicable. My vertical asymptotes in the denominator, if I set that equal to 0, I get x equals negative 1. And then for my horizontal or oblique asymptotes, if you look at the degrees, on top it's larger than the bottom. The bottom's a 1, the top is a 2. So because the degree on top is larger, it's an oblique asymptote or a slant asymptote, and we have to divide to figure out what that asymptote is. So dividing these, so for my oblique asymptote, we have to divide. So x plus 1, how does that go into x squared plus 4x minus 5? So x goes into x squared, x times, distribute. we get x squared plus x, subtract. So then 0, 4x minus x is 3x. Divide, x goes into 3x 3 times. And so you're going to get y equals x plus 3. You don't have to worry about the remainder. The remainder is meaningless. It makes more sense why the remainder is meaningless once we get to calculus. But the idea is once we take things to infinity, that remainder basically goes to 0. So why am I going to add 0 to anything? Why write it? So that's pretty much why we have that. Now graphing this, see if I can be neat about it. So I need to make a table. So putting some of these values on there, I need to see what values I need to pick. So I have a vertical asymptote at -1. And then at y or x plus 3, I have my vertical asymptote. You know, this thing might not even fit on the graph. Shoot. But anyways, that red is the asymptote. You wouldn't draw it solid, you'd draw it dotted. It's kind of hard to draw dotted on this touch screen. But now I just want to pick values. So I'm going to create my XY table. And I want to pick values on this side of my vertical asymptote. So like -2, -3, -4. I want to pick values on that side of my vertical asymptote, like 0, 1, and 2. And so we just want to take those values and we want to put them into our calculator. So let me plug them in. So -2, -3, and -4. So I'm going to get 9, 4, and 1.66. And then for 0, 1, and 2, I'm going to get -5, 0, and 2.33. So I just need to plot them now. So at -2, I get 9. Well, that's all the way up here. At -3, I get 4. At -4, I get 1.66. So hug the asymptote, hug the asymptote. And then 0, -5. At 1, it's 0. And at 2, it's 2.33. And so hug the asymptote, hug the asymptote. And so that's basically the graph. If you want to take a look at it on Desmos, looks pretty similar. If I put in the asymptotes, x plus 3 and x equals -1. So it kind of follows that as well. Comments, questions on that? So like I said, I would just use a calculator to find these plotted values. Just use a calculator. I wouldn't waste my time doing everything by hand. Cool. Any other questions? Awesome. Well, I mean, I think you guys are going to do fine. Don't worry about the... I looked at all the questions on the test. They're not too bad. They go from the very basic questions, what are the vertical asymptotes, to you guys have to graph a few of them. It is timed. I believe it's like an hour and 15 minutes, and you have like... Let me just double check. I don't want to quote anything wrong. It is timed. You do have an hour and 15 minutes, but I forget how many questions it is. It's like super doable. $12 questions. You have an hour and 15 minutes to do 12 questions. It's super doable. So, and it'll open up for you guys in about 50 minutes. And you have through Sunday to take it. But once you start the test, you have to finish it. You cannot be like, oh, 30 minutes later, I need to go do something else, and you big up leave. It'll continue counting the time. So you need to finish it once you start it. It's a mixture, I believe. I believe it's very similar to the Alex structure anyways, where some of it you enter it in, some of it is like you draw it on the graph. So it's all of those. It's like basically how Alex would typically give you a question. So I think it's just a mixture. Fill it in. Fill in the blank. You have a couple of them where you're actually going to plot the points in and you're going to draw the sketch of the graph. Things like that. Any other questions? Yeah, no problem. Potato. He's got it. He's got it. Cool. Well, good luck at the test. Let me know if there's any issues or errors. Just reach out to me in Discord. I think you guys are going to do fine. I don't think the test is super difficult or super bad. So, good luck with that. And have a good weekend, guys. See you next week.